Hello, my name is Ellie Mamantov, and I will be presenting the project I have been working on this summer through the RISC program at Carnegie Mellon University. The project's title is Legibility of Path Trajectories Personalized from Multiple Perspectives. Service robots have the potential to take on roles that will increase the efficiency and safety of people. During a pandemic, for example, robots can minimize human-to-human contact by taking on roles such as a store cashier or restaurant server. However, in order to fully integrate into the daily lives of people, service robots need to be able to interact seamlessly with humans. It has been shown that people are well versed in understanding the intentions of other humans, but it is much more difficult for them to understand the goals of a robot. Therefore, a robot needs to be able to convey its intentions to its observers. One way a robot can help its observers understand its intentions is by changing its motion trajectories. Our project focuses on a robot server in a restaurant, and our goal is to generate approach trajectories that are more human understandable and informative to customers. Legible motion is intent-expressive motion. It allows observers to confidently make inferences about a robot's goals. Past research involving legible motion has utilized a wide variety of different methods. However, previous studies have largely ignored human observers' perspectives, even though past work has identified an observer's perspective as one important aspect that affects whether robot motion is legible. However, we believe that there is a benefit to taking into account that an observer has a specific perspective for which motion can be personalized. Our approach to solving this problem involved two main steps. The first was to develop a method of generating path trajectories that incorporates multiple observers' perspectives. The second was to test whether incorporating perspectives increases legibility through user studies. The user study we developed involved a robot server approaching 4 different tables within a restaurant. We used the A-star path search algorithm to generate the path trajectories for our study. The search used a cost function that differed according to which observers' perspectives were being incorporated. Our scenario just had 2 observers, perspective A and perspective B, so the cost functions were created based on the visibility of either both perspectives, perspective A, perspective B, or to not consider either perspective. In the conditions that incorporated perspectives, areas that were visible to the observers were labeled as low cost, and the path search algorithm was configured to minimize cost when creating paths. Therefore, the algorithm favored going through areas that were very visible to whichever perspective or perspectives it was incorporating. When planning the paths for the no perspectives condition, the most direct path was chosen. In the figure that depicts the 4 paths the algorithm generated to approach table 1, the yellow path is the no perspectives condition, the green path was generated for perspective B, the blue path was generated for perspective A, and the pink path was generated with both perspectives in mind. And here are figures depicting the paths for each of the 4 tables. With 4 conditions and 4 tables, we had 16 paths in total for our user study. To test whether incorporating perspectives when planning path trajectories increases legibility, we developed and deployed a pilot user study using the open source software SciTurk. We created a restaurant simulation using Unity game engine software and filmed a robot server approaching different tables along the path trajectories we had generated. Each participant watched the robot travel along all 16 paths from one of 2 perspectives, which you can see in these images. During the study, participants reported how confident they were that the server was approaching their table. The image displays what a participant saw during each trial of the study. Our preliminary pilot study failed to provide convincing evidence that the paths planned with multiple perspectives in mind are more legible than the paths planned with 1 or no perspectives in mind. Qualitative and quantitative feedback from participants suggests that the task was significantly more difficult for participants who viewed the scene from perspective A, which we were not expecting. In addition, the paths appeared very similar within the restaurant scene to participants, and will likely need to be more different for an effect to be observed. The pilot study will inform the design of a full user study that will be conducted in the future. This material is based upon work supported by the National Science Foundation and the Sony Corporation. Thank you to all of the RISC organizers for this experience, and special thanks to everyone at the Human and Robot Partners Lab at Carnegie Mellon for their help and support.